Hello, my name is Jennae Whitted. I am a senior at Trinity Washington University in Washington, D.C., and I am currently majoring in biology while also minoring in bioinformatics. And this is my application video for the Trinity Washington University and Johns Hopkins Summer Undergraduate Research Excellent Program, SURE for short. And this is the video describing what I would do if I had unlimited resources to solve a scientific problem. So if I had unlimited resources, I would try to conquer the scientific problem of bacteria demonstrating increasing antibiotic resistance. This is something I feel is very prevalent today as we are currently dealing with the COVID-19 virus and its different variants. And we want to make sure that when we are giving out cures or vaccines for alleviating the symptoms of COVID-19 or other various diseases and epidemics, we want to have an overall effective wellness. So I would conquer this problem through the synthesizing of antibiotics or microbial treatments that would target the microbial RNA, short for ribonucleic acid, of the bacterium or virus. So to do this process, I have a 5-step plan. My first step being I would research the bacterium or virus and its effects on environmental and mammalian health. More than likely testing it in cell culture to see if there is increased cell death or if it inhibits the properties of a cell in any shape or form. Next, I will perform agroshell and various PCR tests to determine the ribosomal RNA gene for identification. This is important because this would determine the type of antibiotic treatment or microbial treatment I would need to use, as it would affect this specific gene, as we don't want to always use a treatment that affects every single RNA gene within the body, as that can lead to catastrophic results. A common RNA gene within the body is 16S RNA, and it is used often to develop antibiotics or microbial treatments for human consumption or for human use. Third, I would test various antibiotics to demonstrate a high zone of reactivity. In this, I would have a cell culture of the bacterium or virus itself, and I would use antibiotics in small little circlets around the entire plate, and I would see which one showed increased demonstration of being able to defeat the bacteria, if you will. Fourth, I would apply antibiotics to cell cultures filled with bacterium. Again, it's another version of the antibiotic test that I will be performing beforehand, but this time on a more larger scale, just to see how much of a dosage it would take for the antibiotic to become truly effective. And finally, I would update this research with other antibiotics as new variants forms. As the current problem that I'm trying to solve is bacteria demonstrating increasing resistance to antibiotics, I think it is necessary to continue to use other antibiotics to test for resistance within these same different cultures, because what might work for one person will work differently for someone else. And we want to make sure that everyone is able to obtain overall healthiness whenever they are concerned with this infection or virus. So, why exactly is this scientific problem important to me? Actually, it's important to me because as an aspiring toxicologist who has a passion for seeing how drug discovery and development, including pharmacological toxicology, relates to overall environmental health, I want to see how the outside environment truly affects the inside systems of the body or the inside systems of other cells. So for example, there is the skin disorder eczema, of which the skin becomes on the outside cracked, dry, and rough, and can sometimes form painful bumps, blisters, or can even peel off. And while I notice that there are many different various eczema treatments relating from steroid creams to just using extra moisturizer each day, I also noticed that many of the products that are detailed to help stop eczema don't always work for everyone. For example, a side effect of eczema that many people commonly experience is hay fever or allergies to small pollen or dust mites. And over-the-counter antihistamines are used to alleviate these symptoms. I've also noticed that certain brands of antihistamines are viewed as being better as others because they are advertised for. For example, the Zyrtec antihistamine is very prominently advertised within my area. However, according to a few sample tests around my environment, I've noticed that a lesser known brand of antihistamines actually works more effectively than the Zyrtec antihistamine itself. Also, the lower brand antihistamine costs significantly less than it would for a full 36 pill amount of Zyrtec. So in essence, my reasons for solving the scientific problem is to, one, find various solutions to current viruses or bacteria that are providing resistance to current treatments today, and to find cheaper ways of also getting this cure in a way to other people. Because in order to protect our environmental health and our overall health, we need to make sure it's something we can actually obtain. Thank you so very much for listening to my video.